All right, guys, here's your last section before we go on Christmas break. I know that there's 2 other sections in this unit, but we're not going to do those until after we come back from Christmas break. So 4-7 is the last one that we're going to do for this unit. And we're talking about linear and nonlinear functions. Well, hopefully you can remember back whenever we talked about what linear meant. Linear means straight line. So linear functions are going to be any function that has a straight line. It can be a straight line like this. It can be a straight line like this. It can be a straight line like this. But linear is when it is a straight line, okay? Hopefully, by seeing the word line in the word, that will help you remember that linear means straight line, okay? So nonlinear functions is when we're going to do a graph that is not a straight line. They might look like this when you graph them. They might look like this when you graph them. There are lots of different examples of nonlinear equations and functions, but what that means is that they are not going to make a straight line when you graph them. So let's look at the first one. It says, is the rate of change for the height of the football constant? Does it stay the same all the time? Well, here's the height, so we're going to look at those. From 0 to 6.2, that's a change of 6.2. From 6.2 to 9.7, though, that's not a change of 6.2. In fact, that's only a change of 3.5. So right away I can tell you that it is not linear. And it's not linear because it doesn't increase or decrease by the same amount each time. Okay, so it's not linear because it does not increase or decrease by the same amount. Like I said, from here to here it was plus 6.2, but from here to here is plus 3.5. Since those are not the same amounts, it is not linear. And it says it's a constant. Well, let's look at distance. It's talking about the distance now, because this one it has height and distance. So now if we talk about distance, from 0 to 13, that's a plus 13. From 13 to 26, it's a plus 13. From 26 to 39, it's a plus 13. And from 39 to 52, it's a plus 13. And 52 to 65, it's a plus 13. Because all of these numbers are the same, yes, it is constant because all the numbers are the same. If they were different, like what we had with height, then it would not be constant. But because they are all plus 13s, it is constant. So now it asks you to graph them. It wants you to see the difference in the lines. Well, obviously, hopefully, you know, if it's not constant, it is not linear. If it is constant, it is linear. So based on this one, the height, we already know the height is not constant, so we are not going to get a straight line. The distance is constant, so we are going to get a straight line. But let's go ahead and graph it just to be sure. So at 0, it should be at 6.2. Or I'm sorry, 0.5, it should be at 6.2. So here's 0.5, and I'm going to go up to about 6.2. Okay? At 0, 0, it was 0. So over here at 0, 0 is at 0. So I start right there. My next one is at 1. At 1, it's at 9.7. So here's my 1, and I'm going to go up to 9.7. Let me click off of that real quick. Sorry about that, guys. Okay, so let's continue graphing. At 1.5, it's 10.5, so I go all the way up to 10.5. So here's my line so far. You can already tell that it's not a straight line, but let's keep graphing. At 2, it's at 8.7, so now it's starting to come back down. The height of the ball, they're starting to kick lower and lower, okay? And then finally at 2.5, it's at 4.2. So at 2.5, it's at 4.2. So here's my graph of the height of the ball. Now let's do distance, how far it's kicked. Well, at 0, we've already done this one, so this one's done. We just graphed that one, the curved line. So now we're looking at time and distance. So time is at 0, distance is at 0. So down here I'm going to put a point at 0, 0. At 0.5, it's at 13, so I'm going to go up to 13. At 1, it's 26, so I'm going to go up to 26. It will be, that one's not very straight because I freehanded it, but it will be a straight line going up. This one then is nonlinear. Move my book up a little bit. This one is nonlinear because it's a curve. This one is linear because it's a straight line. Okay? So now it does some more examples for us talking about linear and nonlinear. Let's go down here to these tables. And we want to decide if it's linear or nonlinear. Remember, if it's linear, it's going to change by the same amount each time. If it's nonlinear, it's not going to change by the same amount. So let's do my change in x. Well, my change in x here is a plus 5. My change in x here is a plus 5. My change in x here is a plus 5. So far, so good. We're looking like it's going to be a linear function. My change in y here is a negative 4. Here is a negative 4, and here is a negative 4. These are all the same numbers, so therefore this one is linear. Not too bad. Let's look at this next one. 0 to 2 is a plus 2. 2 to 4 is a plus 2. 4 to 6 is a plus 2. On the bottom, 0 to 2 is a plus 2. 2 to 8 is a plus 6. 8 to 18 is a plus 10. These are not all the same amounts, therefore this one is non-linear. Okay? Now let's look over here. It says these are tickets to a school dance and how much they cost. They cost $5 per student. And it says, are the ticket sales a linear function? Well, again, I'm going to compare the changes. So my change here is plus 1, plus 1. My change here, 5 to 10, is a plus $5, and 10 to 15 is a plus $5. So hopefully you know that it is a linear function, because for every one student it goes up $5. All right, let's look at the very last one. Example 4, we're going to actually graph one to see if it's linear or nonlinear, and you can tell on this one that they graphed this equation on the example. This equation, hopefully as you can tell, it has a curve in it, so therefore this one is non-linear. Remember, linears are straight lines, non-linears are curved lines. So let's look at this next question. It says, a square has a side length of s inches. Okay, so we're talking about a square. And it's s inches long. Okay, the perimeter of the square is a function of the side lengths. Does this situation represent a linear or non-linear equation? So the perimeter, hopefully you know that perimeter is when you add it all around. So I have an S plus S plus S plus S. Because it's a square, all the side lengths are the same size. So am I increasing by the same amount? Am I going up by the same amount for each side? Well, hopefully you know that this side is S, this side is S, this side is S, this side is S. Therefore, it does increase by the same amount each time because it increases by an amount of S. If it were a rectangle, it would not be linear because a rectangle, this side might be S, but obviously this is not going to be the same amount because it's a longer side. So it would not be linear. But a square has the same amount on each side. Therefore, it is linear. And it's linear because it increases by S each time to get the perimeter. Okay? All right, try a few of these on your own, guys. Come back with any questions that you may have. hope your family have a blessed holiday, since I probably won't get to talk to you on a video at least until after Christmas. Have a great break and come back with your questions. Talk to you later. Bye.